In this question from JEST 2024, we have a point mass small m constrained to move along the x-axis. So there is a point mass small m. It is constrained to move along the x-axis, so it can move here or it can move here, but it cannot go in the vertical direction. And it is under the influence of gravitational attraction from 2 point particles, each of mass capital M, fixed at the points x equal to 0, y equal to a, and x equal to 0, y equal to minus a. So there are 2 particles, both are of mass M. One is located at x equal to 0, y equal to a. Another one is located at x equal to 0, y equal to minus a. Now, because of the gravitational attraction from these 2 particles with masses capital M each, the small m, it is undergoing small oscillations. It is undergoing small oscillations, and we have to find the time period of small oscillations of the mass small m in units of pi into root of a cube divided by 8 gm, where g is the universal gravitational constant. Now, time period t is equal to, this is equal to 2 pi by omega, where omega is the angular frequency. Omega is equal to root of k by m, and k is obtained from the equation fx is equal to minus kx. So first we need to find the force, and then we will write it in this form, and we will compare to k, and we will find k from there, then we will put it in this equation to obtain omega. Once we obtain omega, we can find the time period using this relation, t is equal to 2 pi by omega. Now to get this force, we can use potential. When we take negative gradient of potential with respect to x, we will get force. So this is our approach to solve this problem. Now let us find the potential. Let's say the small m is located at x, 0. The potential at a distance r due to a mass capital M is given by minus gmm divided by r. This is the potential due to a capital mass M at a distance r from the small mass m. Now the gravitational potential here is due to 2 masses. One mass is here, another one here. So total potential at x, 0, this is equal to v1 plus v2, where v1 is equal to minus gmm divided by r1 plus v2 is minus gm small m divided by r2. Here r1 and r2 are the distances from here to here. This is r1, which is equal to root of x1 minus x2 the whole square plus y1 minus y2 the whole square, which is x square plus a square. Similarly, r2 is equal to, r2 is the distance from here to here, which is also coming out to be equal to root of x square plus a square. Therefore, we have total potential is equal to minus 2 gm small m divided by root of x square plus a square, which can be written as minus 2 gm small m x square plus a square raised to minus 1 by 2. Now force is Fx is equal to minus dv by dx, which is equal to minus of derivative of this thing, it is minus 2 gm small m x square plus a square raised to minus 3 by 2, minus 1 by 2 is here, and then when you differentiate this, you will get 2x. This 2 and this 2 gets cancelled, 1 minus and 1 minus n gets cancelled. Therefore we have minus dv by dx is equal to minus of 2g m small m divided by x square plus a square raised to 3 by 2 x. When we compare with fx is equal to minus kx, we find that this is k. Now we are told that this is small oscillations. In the case of small oscillations, x is very less than a. Therefore we can treat x square plus a square as just a square, and then we will get k is equal to minus 2 gm small m divided by a square raised to 3 by 2, which is simply minus 2 gm small m divided by a cube. So x square is neglected in the case of small oscillations. X square in the denominator is neglected. Now we got k. T is equal to 2 pi by omega, and omega is equal to root of k by m. Therefore T is equal to 2 pi into root of m by k. Then T will be equal to 2 pi times root of m divided by the value of k is minus 2g. Actually this minus is not there. When we compare with this formula, we will not include minus with k. Therefore this is plus m divided by 2g m small m divided by a cube, which is equal to 2 pi times root of a cube divided by 2g capital M. So this is time period. Now we need the time period in the units of pi into root of a cube divided by 8gm. So to bring an 8 here, we will multiply by 4 and divide by 4. This will give us 2 pi times root of 4 in the numerator will come out, and it will be equal to 2 times root of a cube divided by 8gm. So in the units of pi times root of a cube divided by 8gm, time period is equal to 4. The correct answer here is 4. 4 is the right answer.